Our first speaker is Matthieu Jonglez, who is co-founder and CTO of Smartlogic. He's also the designer and chief architect of Semaphore. This is Smartlogic's content intelligence platform. Our second speaker is Jan Aasman, who is CEO of Franz. And Franz are the leading supplier of commercial, persistent, scalable graph database products. Jan has a huge experience in providing the storage layer and the powerful reasoning and visualization behind semantic web applications, and we look forward to the two of them taking us through this agenda. Graph search has been recently popularized by Facebook and others, but it's also relevant to information management within the enterprise. Companies are looking to graph solutions to facilitate the understanding and to look at the connectedness of their data. And graph also promises a means to manage complex relationships between elements of information, but only if those elements can actually be identified, labeled, and prepared properly and brought into the graph. And that's where content intelligence comes in. So using real client use cases, our webinar is going to demonstrate how organizations use two types of semantic application, namely content intelligence and graph databases, to organize enterprise information.
Thank you, Jeremy, for the introduction. I am Matthieu Jonglez, CTO of Smartlogic. At Smartlogic, we believe organizations can outperform others if they fully utilize a huge business value contained in unstructured content. To realize this value, we know you must understand your content, the information and knowledge it contains, and how it can be applied in the specific context of your operations. We focus on our energy on creating value from unstructured content, and that's something we call content intelligence. Semaphore is our content intelligence platform, and it captures the context of your business, then analyzes unstructured content to identify and present its value in any context. Let's take a look at how Semaphore enables that. Semaphore is articulated around three main capabilities. Ontology management, offering multi-user and multilingual ontology management with full lifecycle capabilities, and allowing you to take existing ontologies or vocabularies and load them, as well as develop specific and proprietary vocabularies and map them across to published ontologies. Semantic enhancement, in other words, applying the ontologies to help users explore and find information by exposing the ontologies in browsable ways, offering search as you type over the ontology to disambiguate search queries, etc. Content classification, to apply those ontologies again, but this time to any type of content, unstructured, semi-structured, in order to generate metadata that represent the knowledge locked in those documents. Structured content can be classified too, to enrich it according to the ontologies held in Semaphore. The classification server can perform three broad types of classification: thematic or subjective classification, which is the most advanced type of classification and aims to assess the aboutness of documents; citation-based classification, looking for mentions and performing entity resolution; and the last type is simply entity extraction, analyzing the sequences of part-of-speech tags with signed to words to identify salient noun phrases and type them. All those types of classification are available in the 25 languages we currently support, with varying numbers of entity types depending on the language. In enterprise search scenarios, the content can be classified as it is crawled and indexed. Semantic enhancement helps guide and disambiguate user intent as the user constructs his query, and helps create context as the results are presented on screen. In content management systems, document management systems or workflow systems, content can be classified and annotated as it is being created or edited, and the semantic enhancement then helps users review and interact with that classification. With a common metadata now available across all enterprise systems, data can be readily exchanged, and the ontology effectively acts as the lingua franca, or the unifying language, across all the systems. Let's now dive into the high-level architecture. The Ontology Manager is a desktop application allowing taxonomists, information scientists, or business analysts to build and manage ontologies. TextMiner is there to assist them in the task by surfacing candidate terms and candidate relationship they could include in the ontology. The ontology server itself is a central repository for the ontologies and encapsulates all the business and validation logic required to operate in a multi-user environment and manage the term lifecycle that's associated with it. Here is an example of an ontology NASA developed in Semaphore. On the left-hand side, we can explore the hierarchy. Once a term is selected, moving over to the right, we can see the preferred term name, the class. In the hierarchical panel, we can review and manage the parents and children for this term. Terms can live in one or many hierarchies, and Ontology Manager fully supports polyhierarchies. In the associative panel, we can review and manage how the terms link across to other concepts in the ontology, and what is the nature of that relationship. In the bottom panel, or equivalence panel, we can review and manage synonyms, antonyms, and other abbreviations or acronyms for this term. Under the Term Information tab, we can find additional information about the term, such as descriptions, notes, URLs to microsites, or illustrations. Under the Semaphore Settings tab, that's where information scientists go to define the classification behavior for the term, and as well as how the term will be exposed to users and drive the user experience. Finally, all the term lifecycle information, including a full audit trail of changes, is available under the Properties tab. As mentioned earlier on, public ontologies can be loaded in Semaphore, as is the case here with MESH, the medical subject headings published by the National Library of Medicine. Those familiar with its structure will recognize the concept schemes and the hierarchy. If I drill into chemicals and drugs, I can find carbohydrates, for instance. Once all the terms are approved, they can be published to the semantic enhancement server so user can start interacting with them, and to the classification server so content can be annotated with those terms. Language packs encapsulating the tokenization, lemmatization, part-of-speech tagging for specific languages are deployed on both the semantic enhancement server and the classification server. All the server-side components of Semaphore have public APIs, and we use those APIs in the Semaphore workbench. The workbench is a suite of web-based applications aimed at a subject matter expert audience. The classification review tool is essential in monitoring the accuracy and quality of classification. And the ontology review tool allows SMEs to review the ontologies in a visual way, make suggestions, and provide feedback. This is an open review of the NASA model we looked at earlier on in Ontology Manager. I can browse for a term of interest or search. In this case, I'll search for Neil Armstrong and select Neil from the list. I can visually browse the term. I can review the term information, its class, the synonyms, the metadata, and I can also visualize and explore its relationship. Let's move over to Apollo 11. And again, same interface, and I can decide to leave a comment, be it general feedback or structured information suggesting links to other terms from the model. The APIs are also used in our out-of-the-box integration with SharePoint 2007, 2010, and 2013, Solr, Fast, Google Search Appliance, or Smartlogic. But they can also be used by our customers and system integrators to expose Semaphore in any other enterprise system. Finally, and I kept it for last as it is the subject of this webinar, here comes at the bottom left the triple store, the graph database. The publisher commits the ontology to the graph in the same transaction covering the semantic enhancement server and the classification server, ensuring that all users and enterprise applications are always presented with the very same version of the ontology, regardless of which component they access. and the classification server output, RDF or RDFA, can be distilled and ingested in AllegroGraph too. Let's look at that integration in more details. The blue box at the top section of this diagram represents Semaphore as detailed on the previous slide. Starting from the right, as the data assets are ingested from the corpus, they are presented to classification server. The classification output, the URIs of the terms from the ontology, or the extracted entities returned as literals, is used to create or enrich the RDF descriptions of those data assets as they are added to the graph. Here at the top, the publisher commits to the graph any change in the ontology. And over on the left, researchers and data analysts can use graph to explore the graph and discover information and its connections. More casual users and more general audiences will use purpose-built, search-based application to gain knowledge from specific aspects of the data using pre-established query plans. Those users will first interact with a semantic enhancement server to identify the nodes from the ontologies that are relevant to their information need. By integrating the Semaphore Content Intelligence platform with AllegroGraph in this way, we are unlocking the value from unstructured content. And by applying coherent classification metadata, we are allowing joining of data from many data sources and allowing semi-structured and unstructured information to be combined with structured data in order to answer queries that could not previously be answered. Jans will now guide us through what a graph is and what AllegroGraph offers.
All right, thank you, Matthieu. So my name is Jan Aasman and I work for Franz. And our main product is called AllegroGraph, our graph database. For many years, I had a hard time explaining why it was so important to work with graph databases. But recently my life got a little bit easier because Google started with their knowledge graph. They're actually gathering information about 500 million entities in the world with everything they can find about it and the relationships between them. So suddenly, for them, the graph became very important. You probably have seen this on the right-hand side of your Google screen. If you look for an important person, you see lots of things that people, well, all the things that Google knows about this particular item. I think my GoToMeeting is a little bit slow right now. Okay, there it is. Then Facebook started probably 1 or 2 months ago with graph search, where you can actually find the things that you like and that other people also like. And it's kind of creepy, but on the other hand, it shows you again how important the graph is. And then there's LinkedIn. I guess almost everyone on this call will be in LinkedIn. And LinkedIn has implemented one of their own graph databases, mostly entirely in memory, where they can link almost 300 people together in sometimes beautiful graphs. This is the graph about me. Unfortunately, I can't show you the detail, but basically it's your life story that you can see all the way down in a graph. So these are the big companies, that the big web companies that use the graphs. But we also have scores of customers that start to using the graph in their day-to-day business. One of our biggest examples is a company called Amdocs that is working for big telecoms. And with them, we built a system that integrates information from more than 40 different databases that you need to run a telecom and integrate that data into about 5,000 to 10,000 tuples per customer. And so on the left-hand side, you have the really low-level IT data. On the right-hand side, you have the way business people think about you and express this as business concepts. So it's not only the web companies, but also normal companies, enterprises that start using graph databases in their day-to-day work. And, well, I think I almost don't have to explain a graph database anymore, but for the few who don't, you are obviously familiar with relational databases and the fact that everything is stored in rows and columns. Well, in graph databases, the basic entity is nodes and links between nodes. Yeah. So, for example, here you see a little graph of politicians that are various committees and subcommittees, and how they all kind of are linked together. And then our graph database is an advanced type of graph database, given that we do RDF too. So we're an RDF graph database. That means that the nodes and links in our graph database are URLs or URIs. And so you have, say you have a node, a link in a node like Jans knows Matthieu. Yeah, then Jans would be the subject, knows would be the predicate, and Matthieu would be the object. But we would have complete URLs for them. And that makes it very easy and straightforward to link data sets that people make in different places. So as long as you use the same vocabulary and thesauri or taxonomies, and you use the same words, you can link databases together in various places. And I will demo that in a few minutes. And this whole RDF is based on W3C recommendations. About 10 years ago, you couldn't find anything about semantics and RDF on W3C websites. Now it's probably a third of all the web pages. One standard, so RDF is the standard of how you represent things as triples, or nodes and links. RDFS is a layer on top that almost lets you look at your data as if they were objects. And then there's even a higher layer on top, still expressed as triples, and it's called AL, and it's like a layer of logic on top of your triples. And then there is a standardized language called Sparkle, which is very close to SQL, but it's much more focused on doing queries over graphs. So let me just give you a small example. Say I want to represent that I'm a person who lives in Moraga in California. I work for Franz in Oakland in the USA, and I have a son who studies at Cal Poly, and I'm born in a place in the Netherlands. Now what you'll see in my demo is that we have an ontology or a schema about people and places and organizations. And they're represented as triples or graphs. And then I have information about the instances also represented as a graph. Yeah, so let me start with the ontology. Yeah, so here we have a person who has a predicate has child, and actually somewhere we have said that child of is the inverse of a child, and a person has a place of birth, and three people have last name and first names. And then there's other classes like well, universities, which are subclasses of organizations. And just for fun, I added that persons are the same as human, which are the subclass of mammal and animals. Now, I think most of the people in the audience are using Smartlogic already, and so they know all about taxonomy. So let's not go too deep about that here. And then let me fill in the information about myself. Yeah, so now here you see person 1 is Jan Aasman. He works for a company called Franz Inc., who is located in Oakland, which is in California, which is part of the USA. And then he was born in a place in the Netherlands, and both countries are part of the NATO. So what you see, NATO. So what you see here is that you can kind of glue data together and represent fairly complex information. So now a real demo. So and it's a demo from the linked open data cloud. I don't know if the people in the audience know about this, but in about 7-8 years ago, people started taking publicly available data sets, but also some proprietary data sets, and turn these things into graphs. Yeah? So, for example, the DBpedia is currently a source with about 1.8 billion triples describing everything in the Wikipedia. So you would have something like here, a triple that would say like Oakland is of type place, and Oakland has population 1.2 million, and Oakland has a geonames ID and then a long number. And then what you see here is another database called geonames, yeah, which is a database with 7 million places on Earth, and it also will have Oakland, but with information about latitude and longitude, alternative names, etc. And the link between them means that because you used the ID for Oakland here, you can refer directly to something here. The U.S. Census database is also about 1 billion triples that describes the U.S. Census from the year 2000. And if you, for example, want to know what is the average income of the place where Obama was born, then you actually can do this query by looking at these 3 databases at the same time. Yeah. So I hope what you see here is how useful it is to link to have unique URLs that can point to other data sets. So this was October 2007. Then what you see here, is the linked Open Data Cloud from 2011, and this whole cloud is probably already 30 to 40 billion triples. DBpedia is still in the middle. One, because the DBpedia made this picture, but also because it's a fairly important data set. Yeah, that almost links to every other data set here. So all these pinks one are life science triples. All these data sources are publications. This is all government data. This is multimedia data, etc., etc. There's lots and lots of data that's available. And in the demo that I'm going to give you, I'll show you 5 databases that I downloaded from the web. A database with side effects, a database with 1,800 FDA-approved drugs, a database with the medicine you buy in the pharmacy, a database with 4,000 diseases, and everything is tied together with LinkedIn. With the linked clinical trials. So about 100,000 clinical trials. With clinical trials, talk about drugs and about side effects and diseases, etc. Yeah, so let me give you this demo. We'll go in here, and let me go to this view here. So normally you could create a new triple store, and then once you had the new triple store, you could say load triples, and you could load some triples, and you could load it from the web, and you provide a URL, and you can start loading. So the 5 data sets that I loaded all straight from the web. And all these 5 data sets are also indexed, pre-text indexed. So normally when I do it in smaller sessions, I ask someone for their most popular drug, but let me do it right now. Let me search for something like Lipitor. Yeah, and I get a bunch of subjects of triples that talk about Lipitor. So say, let me make this a little bit bigger. So here you see 3 clinical trials that talk about the word Lipitor somewhere. And the first way to look at this is in the tab view. So I can see clinical trial 24531 has the brief title Lipitor's treatment for Alzheimer's disease. Yeah? Or this clinical trial discusses diseases, dementia, and hypertension. And it discusses the drugs that you see here. Atorvastatin is the underlying name for Lipitor, by the way. And here you see the side effects. So I'm now in a clinical trial database, but if I click on atorvastatin, I'm suddenly in the drugs database. And you see here Lipitor is the brand name for atorvastatin. You see the chemical formula of Lipitor. You see the things it might cure. You see the pharmacology of it. You see other clinical trials that also talk about atorvastatin or Lipitor, so I can click on this one. Now suddenly we talk about something completely different. You see that this clinical trial talks about, well, leukemia and HIV and completely other drugs. I can go to, say, HIV, and now I'm in the disease database. You see some associated genes. I go to a gene, etc. So I jump through all these 5 databases, yeah, without having to do anything for the integration, because the names made all these things already kind of point to each other. So here I'm back in the graph view. And let me take a few steps back. Oh, let me put that in the center. I can also explore a graph on the screen. So here you see all the predicates or the names of the links in the entire system. And I selected discusses diseases, drugs, side effects, and targets, and something I'll get later to. So let me unselect this right now for the moment. And if I let the hit the letter F here, I see suddenly the clinical trials and how they relate. Yeah, I see that they these two are about major depressive disorder. These are about hypercholesterolemia, etc. I could look at this one here. I see more links. I'm doing this on a very small screen, so let me go a little bit smaller. Yeah. So here you see kind of the layout of this particular graph. I can take a completely unrelated topic, let's say, what would be a completely unrelated topic to Lipitor? Well, one joke I always make. Can I make this joke here? Okay. So there's one clinical trial that shows if you're more intimate, then your blood pressure will go down. Oh, Lipitor was about blood pressure, so that was not a good choice. Let's talk about heroin. Yeah, as a drug. So let me get some clinical trials, and they're already related to. Let's look a clinical trial that talks about IBM. So here we have one clinical trial about IBM that is not linked to this data set. So what I can do, I can ask the database, find a link from this clinical trial to, say, this clinical trial, and it will find an automatic relationship. I can say, is there a shorter connection between this guy and this guy? And it says, oh, there's 818 paths between these particular nodes. And I can look at this and I say, I can see some paths, like this one talks about weakness and sarcoma, or this one about AIDS and cancer. And so here, yeah, so I let the database find the connections between various things. And then I could make it a little bigger again to see what it was actually about. So this is about the graph on the screen. Then there's the query language. And so let's do a query like so this, for people that know SQL, it might look a tiny bit the same, but we say selectively drug side effect trial and title, where a drug has the brand name Lipitor, and there's a side effect with the name type 2 diabetes, and they give me every trial that talks both about this drug and the side effect, and then give me the brief title for these clinical trials. And I do the query, and here are some results for this particular query, and then I can look at this thing on the screen again. Yeah, so this is one way. Or what I can do is I can do a query like this, where I say, well, I have one particular clinical trial about Lipitor. I think it was about Lipitor. Give me all the other clinical trials that roughly talk about the same diseases, side effects, drugs, and targets. Yeah. And so when I do this query, I get some results where you see that clinical trial 130091 had 19 things with itself in common, and the next one 028 had 11 things in common with the previous one. So if I look at this, they're all unconnected yet. But if I then say, okay, so how are they actually connected? Yeah, it will start finding the connections automatically, and I can keep going. So this is the typical presentation that I give about the graph database. But then what we did with Smartlogic is that they took all the text in the clinical trials, yeah, for example, the criteria or the summary of the text. And what you see, there's a lot of text in these clinical trials. This one is actually not that bad, but most clinical trials have far, far more text. And the problem is that you can't do anything with the text in these descriptions. So what we did is we took the mesh ontology, and let me just for a second show you what the mesh ontology is. Let me just say file, find the, well, Matthieu already showed a little part of mesh, yeah, and he looked at the carbohydrates. So what I'm doing here is I say, give me a mesh thing that has the label carbohydrates, and then give me 4 levels deep all the subclasses of the carbohydrates, And so I did the query. I can look at this particular clinical graph. Let me wait till it's on the screen. Okay. Yeah. And so I could look at, say, I put this thing here. You see lincomycin, and now I have to add some more predicates to this. So let's do this too. And you see in a second why this is important. Yeah. And you see that this lincomycin is a subclass of this, which is a subclass of glycosides, which is a subclass of carbohydrates, which is a subclass of dietary carbohydrates. And then what you see is that there's actually clinical trials that will point to this. Yeah. So when Smartlogic indexed all these clinical trials, they basically made new triples where they say, well, this particular clinical trial mentioned the mesh chemical and drug, and then it pointed to dietary carbohydrates. Yeah. So now I can start combining the normal questions that I do with the indexed questions. So I could do something like the query string. Yeah, this is the same query again that you saw where I looked for lipitor and diabetes and then the trial to talk about it. But then I also say, give me all the psychiatry and psychology terms mentioned in this particular query. And when I do this, well, in this case, it's all about risk management. But this is the mesh factor that the query is then talked about. Or I can do even better. I can do a query like this where I say, yeah, I have this particular clinical trial that I looked at before, but now I want to know all the other ones that, given the mesh categorization of the clinical trials, are roughly the same. So here you're saying, give me the other clinical trials that have the same anatomy elements, the same chemicals and drug, and the same diseases, based on mesh in the unstructured text. And so not in the structured data that I downloaded from the web, but in the unstructured triples made by Smartlogic. And so I do this query, and now I get some results. And when you look at the visual graph, oh, let me just blow this up. Oh, this screen is too small here. But anyway, I hope you get the point. Yeah, I can now do, let me see some things in the middle. So what you see here on the screen is that there is a lot of things in the middle, meaning there's a lot of in and outgoing links from various clinical trials to these elements. And this is where it's all about pain, if you look at these elements here, pain and sensation. So I think that I've done my part of the demo and showed you how you can play with triples and do more queries, more structured queries over unstructured data. Let me then finish with one slide, and then Matthieu will take over again. So, in general, when do people graph databases? Well, number one of every person that is using a graph database or AllegroGraph is because it is so much more flexible. If I want to add in my database just a new data element, I don't have to create a new column and do a lot of work. I can just add anything, and it will work. Yeah. Plus, it's very flexible in the ad hoc queries that you can do. And well, if you have life science data or other very complex data, making a schema for that is sometimes almost prohibitive. But with a graph database, you can link just everything together. Then another reason is people start more and more to integrate data sets, and so they make sure that using tools like Smartlogic that they get vocabularies and thesauri and taxonomies in the enterprise where people all agree on using the same words, and now suddenly it's much easier to integrate data. Yeah? Or what you've seen in my demo is that you can enrich data with the linked open data cloud. So one demo that I do a lot is where I scrape things from the web. We get text out of, we get the entities out of the text, and then we look in the linked open data cloud if I know more about this particular word. It's very easy in graph databases to use rules and reasoning, and obviously in a graph database you can do graph analytics, and a lot of people use it for social network analysis. And then 3 points that we use a lot is that well, a lot of things in graph databases and on the web are all about things that happened, events, and events are always things that happen in a particular place and at a particular time. So we provide all kinds of tools to make it easy to work with place and time. And then if people want to write algorithms themselves, they can do that in JavaScript. Okay, Matthieu, can you now take over again?
Thank you, Jan, for those explanations and examples. In the final part of this webinar, I'm going to walk through a healthcare management scenario. I've called the scenario falls, trips and slips after a term from the UK National Health Service ontology. The NHS is using Semaphore to power content discovery on their public health portal, and this is serving 65 million citizens here in the UK. And we will see this term in action, so to speak, in the closing slide. Every year, 1 in 3 persons over 75 years old will experience a fall. And 4 times out of 10, this will lead to a trip to the hospital, a long period of immobilization, surgery, or worse. Clinical studies have identified 4 main categories of risk factors contributing to falls. There are demographic factors, historical factors, physical deficits, and environmental hazards. Examples for each are listed here on the slides, but anyone over 75 years old and also falling under at least 2 of the other categories, no pun intended, is considered at high risks of falls. So in this use case, I'm going to illustrate how the at-risk population can be identified, so a healthcare provider can reach out to them and manage and mitigate the risks. In doing so, I'm going to focus on 2 core risks, medication and environmental hazards. Here is a list of the main drugs and drug families known to increase the risks of falls. And this is how these medication risks can be modeled in Ontology Manager. Capitalizing on the mesh public ontology we looked at earlier on, I created a new prevention branch. And underneath it are terms falls, trips, and slides. Here on the right in the associative panel, we have connected our term to drugs and drugs families already present in mesh, using a risk-increasing drug ontological relationship. And the environmental hazards are modeled in a similar way. 2 types are created here, indoors and outdoors, and non-preferred terms are used to describe the possible manifestation of those risks, absence of handrails, loose carpets, steep stairs, etc. Data points are available. Data points about the patients are available. Doctors and medical practices have structured patient records with a full medication history and some partial unstructured information covering the physical deficits. At-home carers and visiting nurses have a fair amount of unstructured notes covering most physical deficits and some of the environmental hazards. And social workers have reams of unstructured notes covering most of the neurological changes and many of the environmental hazards. But they are all locked in their respective data silos, and they cannot be seen in perspective or jointly analyzed. The Semaphore and AllegroGraph integration can break that status quo. The 3 main data sources over on the right-hand side, patient records, nurses and carers notes, and social worker records, can all be classified and annotated by Semaphore, so they can be ingested by AllegroGraph. Once they are in the graph, data scientists and business analysts can explore the ontologies through Graph, the tool that Jan showed earlier on. And here you can see the terms we added in mesh earlier on, our falls, trips, and slips term, the indoors and outdoors tripping hazards, and in purple, the links out to the existing mesh drug and drug family terms. And our data scientists can also start exploring the content to identify pattern, connection. In this particular case, we started with one of the patients, Brad Tatton, looked at the drugs that he was taking, links of drugs all the way back through the subclass of relationship to the clinic to other drug families and to the corresponding clinical trial. So not only does it allow us to explore from a patient perspective, but it also allows or GPs and doctors to actually link all that information back to the clinical trials and get insight about possible treatments. Using the graphical query builder, our business analysts or data scientists can also express complex queries. Here, for instance, this query is designed to retrieve the names of all patients who are taking at least one drug known to increase the risks of falls and whose health visit notes were classified by Semaphore as placing them in one of the two environmental hazards at risk category. And here is the same query expressed this time in Sparkle, and showing the actual list of patients we can now tell are at risk. So with this list now available, the healthcare provider can now take risk mitigation measures, proactive home improvement and repairs, and liaising with local authorities to improve access. So they could reduce environmental factors and fitting a handrail with a fraction of the cost of a hip replacement. Line of business application can tap into the graph in real time to flag at-risk patients in computer screens as doctors perform health checks or prescribe new drugs. And the graph can also power self-service portals, tailoring the user experience and the contextual information based on the individual's risk profile. And this can be a very powerful mechanism in creating self-awareness, as is illustrated here with the NHS Health Explorer screenshot showing our full strips and slips term. In this use case, by integrating the Semaphore Content Intelligence platform with AllegroGraph, we were able to unlock the value from unstructured content, the notes from the nurses and the social workers. We were also able to enrich the structured patient records with additional information from the ontology. This, in turn, allows the joining of the data from those historically siloed data sources. It answers queries that could not previously be answered. It provides insights that could not be gained. It can prevent a fall and save a life. The Semaphore and AllegroGraph integration can support similar types of use cases in pretty much all environments and organizations where structured and unstructured data coexist, and where joining the two unlocks business and knowledge potentials. It can help getting better insight into your customers, support decision-making in call centers, reduce warranty problems, assess the root cause of faults to improve manufacturing process, and it can help analyze the adverse effect of drugs and medicines, and those are only just examples.
So that concludes the Franz and Smartlogic webinar. I hope that it's showed you how content intelligence and graph databases can be used within the enterprise, and how we use it to commingle information that's locked up in unstructured content, which can now be structured and brought into the data world at very high volume and velocity, to bring new insights that weren't previously available, and that's highlighted the value. And so that just remains me to thank our two presenters, Jan and Matthieu, and to bid everybody else a good day.